Yeah, it's all a little bit weird just now, but as I've already mentioned, we need to get on with some work. So you're starting national courses. There's certain parts we have to get done up to the summer so that we're actually prepped for next year. We realise it's quite difficult, so we'll keep in communication, but can't really have any excuses. You're supposed to be doing 2 hours of work a week per subject that you're doing in the senior phase. This could mean that you might have more than 2 hours to do, because the key thing is we will give you the amount of work you need to finish, but you will have to focus, you'll have to read the instructions, you'll have to actually try. At this level, we can't get away with just saying, it's too hard, I can't do it. Obviously, we're around. If you email, we'll get back to you and we'll try and help you, and we'll do other things. We might do some video meets and things like that. But what we're mainly going to do with the lessons is we're going to take you through kind of stuff, give you some tasks to do. What we'll probably do is we will release answer versions to help you. So again, there's no excuse. People say, well, it was too hard, I couldn't do it. We will release answer versions so you can read them and then you can fill in your own answers. Obviously, there'll be bits of coding that we need to do. We're going to be starting working in Scratch. We're also going to have to get working in Replit. So we're going to have to take some serious quality time and make sure we get that done. Okay? First of all, you should have been invited to a Google Classroom. There are two of them. One's called National D Computing Science, the other one's called National C Computing Science. They are just named purely whichever column that you chose the subject in. So they're both going to have exactly the same work, but they'll just be split into the two different classes who come at a different times. Okay? Obviously, you'll use Google Classroom a fair bit. There's the message. I started off with the course to kind of warn you that it was coming, and then there will be assignments with the electronic chapters. Best place to go for your assignments is you can click on that and open the assignment. Best place to go is classwork. What will happen in classwork is the posts will all be organised into the 4 different units of the course: software development, computer systems, web design and development, and database design and development. And the lessons are there. When you click on that, there will be stuff to read. You're going to have to read stuff. There is no quick fix for this, particularly when we're working electronically. If you've not done stuff, I will have to record it immediately and I will send you stuff back if you try and hand it in and it's not ready. You technically don't need to hand stuff in, but it can be useful if you think you've done the tasks to hit hand in, but you can't actually work on that until I return it, so that's a bit of a problem. There's usually links. There's the electronic chapter, and that is a link to Scratch. Make sure you can get in. So if you actually view the assignment, I see a slightly different screen to you. What I see is all your work and your booklet, so I can actually watch you working and things like that. Creepy. Here you get your instructions, and what you'll find is up your screen, the actual electronic worksheets and stuff will be here, which you will open, and then you've got your own version of the actual workbooks and stuff like that. So with these lessons, what I'm going to do is just video 5 to 10 minutes, kind of do what I do as an intro in class, and I'm going to set you a way to do a bit of research, try and answer some of the questions that I tell you to do. You can watch this video again, of course, because I will explain things. I'll talk a little bit about the teacher answer versions, because we're going to be using more of that to kind of send stuff out to you. We'll talk about Scratch as well today to make sure you can actually get into Scratch, because you are going to be building a game for me. Although, again, I will probably help you with the coding. So, the electronic workbooks look a bit like this. If it loads up. So, quite a lot of pages. Most National 5s are the same. There are a few hundred pages of notes for the entire course. But the beauty of this is the electronic workbook contains all the theory that you require, any diagrams. It also contains any problems. There are questions where we get you to highlight stuff. There are boxes where you type in answers. So at the end of this course, you should have all of those things in one place. There are even sections, there's tables and there's answer boxes. There are sections where we get you to screenshot stuff. I would suggest that you learn very quickly how to take a screenshot, how to take a snip on a PC, but also if you're working on your Chromebook just now, how to take a screenshot of the Chromebook screen, but also how to take the snip. What I really don't want is full screenshots of full screens. If I say take a screenshot of the code, I'd like just a screenshot of the code, the part of the screen. So I will attach instructions on how to do snip screenshots on Chromebook. And what you can use on the computer is just a snipping tool that lets you just select part of the screen that takes a screenshot, and then you can just click in here and paste it in. So we'll do all that. So that's what the worksheets look like. What I will generally do in class is I'll have a chat about 1 or 2 things. We might write a few notes. I would suggest just now that you might have some pen and papers around, because you might want to note things down that I say, things that are really important. Nobody is intelligent enough just to remember everything that they see. You do have to kind of be a bit conscientious in terms of that. So you read the theory, you look at the diagrams, then there will be questions, okay? So I'm going to just kind of go through what the kind of sections are and show you what tasks you're going to be doing for the first few days of your National 5 computing. So, development methodology is how you approach something. Now, in life, we do lots of tasks, and what we should be doing is we should be thinking about the problem, analysing, we should be planning what we're going to do, so we can think of the best way to do it. Implementing is just writing the code, building something, doing the actual task. Testing is checking it, making sure, does it work? Does it have everything it needs? Documentation is putting in some notes here or there to kind of explain what we've done. We do that with comments and programs. And then evaluation is, it worked? Does it work well? Does it look good? Does it work fast enough? Are the users happy with it, I suppose? Now, obviously, in everyday life, we don't usually do this. We usually do write me an essay and we start jumping in here, we start messing about with stuff. We don't really do enough thinking and planning. But with software development, because it's so complex and because it's a multi-million pound industry, and it's got millions and millions and millions of code, we do need to think about how we actually properly go through it. So although we're doing programs that are quite small initially, you do need to prove that you can actually do the kind of analysis, think through a problem and design it, basically. They call this the waterfall model, and the fancy word for repeating stuff is iteration. Now, the reason that iteration is quite famous in programming is because it's also the fancy word for what we call loops in programs. We call it iteration. Now, the reason this is called an iterative process is because we always go back and double check things. We're always going back to double check. You don't just say, oh, we do 3 months on this, then 3 months on this, and then a year on this. You basically are always going back to double check as you go through the process. So analysis is the first one. The first phase of analysis is basically really thinking about a problem, okay? And like somebody could say to you, this is a program I want, and it might just be a couple of sentences. So this is what we call a problem statement here. But there's quite a lot in that we need to consider, lots of things we have to break down. So the first task here, you'll notice that there's some highlighting, where we're going to go through this problem, and we're going to highlight bits. So it says we have to create a guess the number of a program to guess the number between 1 and 10. The winning number will be set in the code by the programmer, the number between 1 and 10. Inside the loop, the program will keep asking to guess the number, taking the answer as a guess. This will continue until they're correct. So there's lots of things in this when you read it that you have to spend some time thinking about. You need to sit there and go, look, I mean, they've already done this for you, but winning number is obviously going to be a variable. So it's going to be a piece of data that you're going to set. You're also going to have a guess, so that'll need to be a variable. Every time somebody says, I think the number is 8, it needs to be stored so we can use it. Next time they may say, well, I think it's 3, things like that. We need to have a random function in here somewhere, because of course the game is going to pick a number between 1 and 10. We need a loop, because this is very, very, very commonly a program which keeps going until the person gets it right, until they match. And then it gives them a wee message after the loop to say they've done. Okay, so we will help you with this, but the first bit, we often do this highlighting on here. The highlighter tool's up here, by the way. So you highlight bits that you want to highlight. Again, there's no exact thing with this, guys. People get a bit bogged down and, oh, did I do that exactly the same? Have a go at it, have a look at the example, we will help you with that. We then actually plan it a bit more formally. So we're not actually designing yet, we're actually breaking down the problem and saying, what are the inputs, what are the outputs, what variables and structures do we need, and what are the processes, what are the programming things that we require. So even a simple game like this takes a little bit of time. Okay, so we do full analysis. I'm going to help you and give you these bits so that you can just copy them, but again, copying stuff is one thing, guys, you do need to actually think about it. Design. A couple of things with design when you're doing programs. Number one is you need to work out all the data. You need to work out what are the things I need to store, what are the variable names that we've used quite a lot in the previous years we've done computing. So you need to work out the variables. So 2 variables in this program, which I've already mentioned. They have data types, but we'll come back to that later. And then we kind of plan out what it might be. Task 4 is pseudocode. So what we do for pseudocode is we usually write out each line. Now the reason it's called pseudocode, although you'll learn this properly later on, is that it's halfway between English and code. So they write it line by line so it matches the program, but what they also do is they make sure that it's short, really easy to read English, but also uses some of the programming words so that it's easy for us to then turn into the program. So people always focus on implementation. Now, implementation for us is just building the system. It's actually writing the code. If you do the design well, the code could be easy. You should be doing it line by line and just switch it into the full language. But we're obviously going to be working on that. So I'm probably going to help you with tasks 1 to 4. Okay, I'll probably just attach the answer version so you can go through it. A bit like what we call a worked example. We show you exactly how it goes, but you need to read it properly. We are going to ask you to have a go at trying to program it yourself, although we will help you in the next couple of days because we need to get it running. Quite a lot of the course starts in Scratch. Now you remember using Scratch. We are going to use Python, and we're going to use the online system Replit, which most US3s have only just started using, but we need to be able to use Scratch to actually try and create it. So you will have the design, so it might help you try and work it out. I know for some of you it's been a while since you've used Scratch, but we'll give it a bash and then I'll give you a hand with the program. Scratch is just an online environment that works in the cloud. Now, I will be very impressed if you know your sign-in. You will have a sign-in from first year even, or third year, that has a username and a password. It should be set up through your school Google account. What I would do if I were you is I would start by going to Need Help with the login. And what you can try is putting in your email address. Now, the email address should be your school one. Here, but it's the one with the. Better not do this, or I'll reset my password. So it's your first name dot second name at inverness.high.org.uk. Then you can put in here, send me a reset link. Now, if you've typed this perfectly, first name dot second name at inverness.high.org.uk, and it says to you, I don't know that email address, what I would do is just go to Join Scratch and sign up for Scratch. If it remembers you, great. You can go to your Google Mail, it'll give you a link to reset your password and it'll show you your username, and you can get back into that same account. I don't really mind either way. If you want to just go in and try and join Scratch, set up a new account, it might not let you if you've already got one on your school email address. But please note down your username and password somewhere because we can't get into this. You are now in senior phase classes. You don't get away with saying, I don't know how to log in, or I don't know my password. So please write it down because when we get back into school, we'll log onto this, not just on your Chromebook, but also on the PC. So take a note of it. Once you're in Scratch, I don't know which one it is. Let me try something. Seems to be working. Once you're in Scratch, up the top right here is your folder. So all your projects will save pretty much automatically. The Save Now button you can hit, and they will all appear in that folder. If you're going to create a brand new program, you hit Create, and it basically just opens a project. It's going a little bit slow. I've got millions of tabs open. It's trying to work from home. You can do it Scratch, and it goes. Right, first thing, always give it a name. I do not want to see your screen and in your folder you've got like Untitled 46 is the name of your project. So at the top left here, give it a name. So this one you would type something like, it's a number. You'll notice that it comes up here saying it's kind of saving, but you can't hit save now if you're not sure. Now very simply what you do is you go through the blocks, you find the correct ones, and you click them together. Now people are like, oh, Scratch is pretty basic and blah blah blah. To be honest with you, Scratch can teach 90% of this course. Sadly, you have to do text-based programming. So National 4 we can use Scratch, and you can run what you've done and you can see what happens and all the rest of it. So make sure you have a little look around, but mainly we're not going to do any exciting graphics and stuff anyway, we're just writing basic programs, and you're to try and write that. You'll notice it says save now, but it should save pretty much automatically. So the idea is that you will get help with the first 4 tasks, and you can go through them, read them carefully, fill them all in, and then you're going to try and build this program for task 5. Okay, right, we're going to carry on like this. As I said, just email me anytime, get in contact. You need to be able to get set up and you need to be able to get working away. Okay, good luck.